the area of interest that you want to make a map. Okay, you load into the software, and then you just draw the polygon, right, like this. Just make a polygon
เดี๋ยว
that
ตายแล้ว
cover the area that you want, like
ไม่
this,
มีที่ตั้งว่ะ
and then
จะวางทิ้งไว้
they have the function of auto waypoint. That it can calculate the shortest trajectory that cover the whole area. Right? We just select this one. See, the yellow line is come.
ตั้งไง
Alright.
วะ
And from here, what you can do is that
โอเค
you
ไม่รู้ไงมัน
can
ชัดไหม
choose the different kind of camera, supported camera. Okay. Each camera has their own specification. The size of the sensor is different. So the coverage area between each camera is different. Okay. So after you select your favorite camera, and then you can specify the altitude
เห็น
that you want to do your mission, and also you can change the direction of the flight. Okay. If you see here, the area, the distance when we change is also updated. Okay. Number of picture, number of strip. Strip is the each trajectory, number of strips. Okay. And also is calculate the ground resolution to you as well. So you can see every information that you want to see and to check before the flight. Right? And after you are happy with all the function, you just accept the setting, and then you can write the waypoint here. This means that this ground control station, this computer, will connect to the UAV and upload everything, upload your flight plan into the UAV. Just that easy. Okay, and you can start your mission. Any question here? No? There is one question in the morning. The question is that this computer was connected to the internet, right? So we can download the background map. As you can see the background here. Alright? But if we go to the field, we don't have internet. Right? So how to deal with that? The answer is that we can pre-fed the background map, yeah, from here before go to the field. Yeah. Okay. So we will have offline map that can be used. Alright. And all information, all setting, it can be modified. Maybe at this point you want it to fly to 500 meters or something. Everything can be changed. Okay. So, any question regarding to this one? No. Okay. Then let me switch to the processing step, where we already get the image from the camera within this SD card. Okay. this is the raw image that we took from the field. It composed of 845 images to cover the whole area. Okay, and this is one example of the images. You can see we fly at 300 meters. So the width is about three something hundred meters, and the height of the image is about 200 something meters. Okay, and the ground sampling distance is about 6 centimeters. It may mean that each pixel is cover the area about 6 centimeters by 6 centimeters. Can you recognize the pre-mark in the field? Yeah, this is that, show like this. So after Jin, he is now doing the survey in the ground using the GPS by taking the coordinate of the center of the pre-mark, and then we will use that coordinate to specify this pre-mark during the data processing. Okay. These pre-mark, the size is 1 meters by 1 meters. Okay.
So what's the resolution of the camera?
The camera is 18 megapixel.
Optical zoom, sir?
As you can see here, the focal length of the camera is 22 millimeters, and the CCD size or the sensor size is this. Okay, and the image resolution is here. And then we doing the calculation using this formula. We can calculate the ground sampling distance as shown here. Ground sample distance. Okay. So with different altitude that I mentioned in the morning, when you fly at 100 meters, you will got very high resolution, just about 2 centimeters. But when you fly higher to 500 meters, you got about 10 centimeters. But today we fly at 300 meters, so the ground sampling distance is about 6 centimeters. Okay? It means that if you got higher resolution of the camera, you will get more ground sampling distance. Okay? Or at the same ground sampling distance, you can find more, more lower. You can find lower than this camera when using higher resolution camera. All right. This is the first generation of UAV. We used the bird connected with the camera. Yeah, because when we left it at somewhere, it can find the way back home, right? So we just connect the camera with the bird. Okay, and this is the specification of our UAV in the morning. Yeah. The wingspan, the wing is about 2 meters, and it's made of EPO foam, as I mentioned. Yeah, and endurance is the the flight time, it can fly more than 40 minutes. Yeah. In the morning, it's almost 50 minutes. Yeah. From the beginning to the landing. Yeah. And the observation altitude, normally we will work between 150 meters until 300 meters above ground. Maybe you will have question why we don't fly higher than 500 meters, because we can cover a larger area, right? The answer is that if you fly higher than 500 meters, it's real dangerous for commercial airplane, okay? Because normally they will fly higher than 500 meters, okay? And range is mean that the distance between UAV and ground control station. Normally, we will not work greater than 2 kilometers, because if anything happens, we cannot reach the UAV, the point, yeah, in rapidly, okay? But practically, we cannot avoid this distance. Yeah, we normally work maybe 5 kilometers from home. All right. Yeah. But for safety, we have to state that the range should be lower than 2 kilometers. And this is the frequency that we use for remote control and telemetry. Remote control, we use normal Wi-Fi frequency, which is the 2.4 gigahertz. And for the telemetry that we use to communicate with the UAV, we use 900 megahertz, which also the frequency of the cell phone, right? Yeah. The battery is lithium polymer, or shortly we call it LiPo, LiPo, LiPo. Actually, the battery type is very necessary to know, because in the market we have different kind of battery, right? Like in cell phone, normally we use the lithium ion, right? It's safe, not non-explodable. But for this one, LiPo, lithium polymer is explodable. Yeah. But when we compare the energy density per weight, this LiPo is higher than lithium ion. It means that the same size, you got higher energy. You can fly longer. Okay? And this is the specification of the camera that I mentioned.
Sir, can you make the launch remote control?
Yes. But you know why we don't launch using remote control? Because it's dangerous, like I mentioned after we landed. It's very stress for the pilot during takeoff and landing. Because when we change the place where we work, the environment also change. High tree, high glass, water, many factors that stress the pilot. So I want to avoid those stress to the pilot by using the auto takeoff. Okay, but for the landing, it's unavoidable because the environment is very limited. To auto landing, we need at least 300 meters clear, no tree, no high glasses, no high building. But at the area of we working in the morning, cannot. So a pilot is needed. All right.
So what is the total power required by the engine?
Sorry, can you speak slower?
Total power required by the simulator. Power.
Power.
Required
than
by
the battery.
required to launch and to fly.
Battery power.
Battery power. Okay. 10 amp. 10 amp hour. 22.2 volt. Okay. This can support the flight time about maybe an hour. Yes, but the mod flight is about 50 minutes. So there's some power left, about 30%, that we can continue our mission. Yeah. Okay. And this is the compilation. This one is the example of the images that we fly at 150 meters. So the TSD is about 3 centimeters. You can see it's very clear, very detailed when comparing to the Google Earth, right? And this one 300 meters can cover larger area, but the TSD is reduced to 6 centimeters. That's right. Okay, and this is the golf course at 300 meters. Very nice. And one application of this image, can you imagine what you can see? The health of the glass. Right? The health of the glass. Over here is not quite good, and the green here is too brown. It's not light green. Over here is fine. Okay. And this one is agricultural area. Fly at about 500 meters. TSD is 10 centimeters. Can you imagine what we can use, what we see in these images? Over here is like a construction, right? Over here is agriculture, and this one is river. At least we can estimate the level of the river, right? How much of it? We can count for the crop, right? How many trees? Maybe this area, crop is the age of crop is more than this size, something like that. Okay, so we can do a zoning. Oh, this area, the age of the crop is 3 years. This area is 7 years, or something like that. Okay, we can do a zoning. Yeah, in EIS. Okay. Okay, this is the one that we use, the one that we work. We just plan before the flight. We fly and then we process. Yeah, that's all. Okay, now it's time for data processing. We taking the image already, right? But what we want to produce is we call it orthophoto. Orthophoto is the image that was collected for its location, and it was collected for the orientation of the camera. So from that image, you can get very accurate positioning on the Earth, and this position include X, Y, and Z, yeah, in 3 dimension, all right. And from the data processing, you also got the point cloud. Did you familiar with this word, point cloud? No? What is the laser pointer?
อยู่ไหนอะ
Point cloud is the word that come from the laser scanning technology. All right. Imagine if we have the laser scanner, and this is the laser that emitting the laser light. You see the red dot over there. If I know my location, let's say 0 by 0 by 0, then we can calculate for that location, right? At the red point, right? And imagine if this laser was spin around the room, so we can calculate every single point in this room, right? Each single point will have their own location when comparing to my location, right? So the group of the point that we got, we call point cloud. All right. So from the image that we capture in our area, we will have very dense point, okay, which I will show you in the software later on, okay. And also we got the digital surface model. Digital surface model is that when we have the point cloud, we can calculate the triangulation irregular network, or we create the smallest triangle between each point, yeah, to create the surface. All right. So from the normal image, but we want to produce this kind of information, we need some technique. And this is used for explain how can we do that. Okay? Let's say when we see the things using our bare eye, okay, we try to translate the 3D real world into 2D, right? 2D dimension, as shown here. Okay. This means that the how to say the far away object and the closer object, when we turn our eye, okay, when we extract the point, the smaller object will displace smaller distance when comparing to the further object. Can you understand my point? Okay. So from those information we use in our UAV by taking many image. Okay. Each image we extract the point. Okay. And we compare each point. We call matching the point between each image. Okay. So when the UAV is moved at the same point, if it's closer to the UAV, it will displace not much distance. Okay. If the far away object, that point will displace more distance. So from that kind of thing, we can get the point cloud and how can we calculate for the digital surface model. Okay. And this is the image that how to explain what happened. As you can see here, this one is location of taking the picture. Okay. This one is another location of taking the picture. So we will have two pictures here. Okay. And then we will extract the point, several thousand, 10,000 of point from this image and also from this image. And then at the same point, at same location from these two different image, then we can calculate back to get the 3D point. Okay. And this is the idea, because what we want is the 3D point. So it's translate from 2D image into 3D world. So, okay. Okay. And the software that we use to compute this, we have two options here. The first option is free, it's open source. You can search in the Google using this keyword, visual, SFM, and CMP-MVS. This software will extract the point from the image and matching the point and calculate the 3D for you, okay? But it's a little bit headache because it's open source. It's not easy to work. Another option is on your right, is commercial-based software. It's called AIT Soft. And today, I will give you the introduction of using this software. And this is the workflow. The first one is to record the data using the camera, right? This we did it during the morning session, and then we come back here. We're doing this process. We begin with align the photo. Align the photo is to connect the image together. Okay. When we connect the image together, then we extract the point from those image and create the point cloud, okay? And then create the mesh generation to produce the digital surface model. And then we doing the texture generation to produce the orthophoto. And then the other option is to analyze, to create the output that we want, okay, and to use in other application. So from here, do you have any question? No? Really clear? Okay, let me show you how to process the data. It's not finished yet. Even the first processing step, the alignment image. Okay, no problem. As you can see here, the texture that shown here is the point that we extract from each picture and then align it together. Okay. Each image have their own location that we get from the GPS. Okay, as you can see here, the length, long, and height. Okay, so every image has their own location already. See, only the point. Okay, next. Next, we are doing the geo reference. As you can see here, we already set up the pre-mark in our area. It's composed of 8 points of pre-mark, and then we use the GPS to get its coordinate for each pre-mark. Okay. Then we specific or we geo-reference each pre-mark. As you can see, as the